Hey everyone, so in the last video we did a bunch of calculations around calculating the mean and standard deviation and the z-score of the values in our data sets, z-scores in the values of our data sets. And we did this so that we could get a sense of how sort of normal or extreme a particular value was. And one of the things that I think was kind of surprising to me was to understand that a z-score, was to understand that a sanitation score of 84 is actually really extreme based on this data set. Now, whether we want to compare, whether it makes sense to compare sanitation scores only within a given chain, maybe not. Maybe we would actually want to look at all of the sanitation scores, maybe all of the sanitation scores in a given year. How we construct that set that we do the analysis around is important because we may find that the rules changed, right, between 2008 and 2012, and the way that inspections or violations were given out changed. So we would definitely have to do some background research about kind of how this data is collected, how it's organized, understand some of the background material there. But in terms of looking at the data, as I said, we have this idea of central tendency and also the spread of the data around that measure of central tendency. And so we've looked at that for the mean. We're going to look at it now for the median. And when we look at the median, what we're looking at is something called quartiles. So a quartile, basically, if you think of the median as the middle value in the data set, the quartiles are the middle of the top half and the bottom half. Those are our important quartiles. They're called the first and the third quartiles. And what we see here is another way of expressing, it's actually really nice, it's on this quartile page, right, is actually the link to this image. And what it does is it kind of shows us the relationship on a normally distributed data set, shows us what the so-called interquartile range, IQR, which is the values between Q1 and Q3, what percentage of the data that range covers, and then our sort of top and bottom values, which is Q1 minus 1.5 times the IQR, is going to account for almost a quarter of the data, and then same thing on the top. And basically what this means is that it once again lets us know that if we see things that are below this bottom or above this top, those are some pretty extreme values. And it's not to say that values always have to be extreme in order to warrant our attention. It's just to be able to understand where they fall within the sort of data set as a whole. So in order to do the quartiles, we're going to go back to our data set. We've already sorted it. It's extremely important. You have to be working on sorted data in order to calculate medians and quartiles. But basically what we're going to do is come and recall that we have 75 entries, which means that if we start at row 2, we're looking at the 38th entry, which is going to be row 39. Okay, and then in our bottom half, and so maybe this is a case where maybe I'll use a color. I'll use a color ooh, that's not very interesting. Maybe I won't use a color. Here we go. Maybe I'll highlight that as the median. Then I want to take the middle of the bottom half, so if I have 37 rows, then it's going to be the 19th row, which is going to be row 20. And if you look at that, you'll be able to see how to actually make sure you have the right one here. And then once again, 37 rows on the top means that we are going to look at the 19th row. So 40 plus 19 is going to be 59. Okay, so what we quickly learn, and we of course, if we knew, if we're familiar with this, we can see by the sort of disparity in the entries, the number of entries here, right? We know that 99 is going to be everything. It's going to be our median, our Q1, and our Q3, which leaves us in sort of an unusual, sort of an interesting position, because basically it means that our interquartile range, our IQR, so in this case we know that the median is 99. We also know that Q1 is 99, that Q3 is 99, and so if that means that the IQR, which is supposed to be the difference between Q3 and Q1, is going to be 0, and that means that our bottom value, which is meant to be Q1 minus a multiplier of the IQR, and our top, which is Q3 plus a multiplier of that, right? Anything multiplied by 0 is 0. So we also know that our top value is 99 and our bottom value is 99. So what does this mean? Well, all it does is sort of reconfirm for us that something that is below that bottom value, which of course our 84s are below that bottom value, something that's below that bottom value is really, really extreme. Now, the one question that we have, or another question that we have not yet answered in our calculations here is this data normally distributed or not? Now, we can sort of hazard a guess, right? Because we see so many values that are the same and so little distribution. But again, in a case where we have more variation, we want to be more rigorous about that. And this is actually a moment where visualization becomes very important, because in this case, when we talk about the shape of the data, we're talking about, how does it, if we look at it, does it form that symmetrical shape that we've been seeing in these images, or does it form that skewed shape that we talked about in class with things like income distribution? And so the way that we want to do this, we're going to show a version of doing this in Excel, and then in our third week, we're going to look at another program, OpenRefine, that does this for us sort of automatically, which is great. But the way that we want to do it is we actually want to represent our values along a number line. So again, with a quick hit, I can see here that I have, the value 84 exists 4 times, which means because I have 75 total readings, that 99 exists 71 times. But what I want to do is actually go through and say, okay, 84. Now I want to represent all the numbers in between that have no values in the data set. So to do this, I'm just going to sort of set up a little sort of series outline here, and then we're going to quickly generate a quick chart. So I'm going to start with my bottom value, which is 84. And in order to get my subsequent values, I'm going to again use a formula, which I can say, hey, take that and then add 1 to it, right? And I can just copy this down until I get enough entries to get up to my 99, right? So I overshot there, that's fine. And now the problem that I'm going to run into here is that, I hate how this works. This is very annoying. Not a proper delete key on this Mac keyboard. Now, the other problem is that this is a number, so it's going to want to read this. We mentioned in class the other day that sometimes numbers are numbers, but sometimes numbers are labels. In this case, numbers are labels. So in order to get this chart to generate properly, what we're going to want to do, now I just want to note, of course, here, right, I have 4 entries here. I have 71 here, and then I've got a whole lot of zeros. Oops. 71. Okay. So the way that I'm going to sort of get around this, because I'm frankly not a very expert Excel user, I don't use it more than I have to, is I want to actually make sure that the computer is going to recognize these as text. And so the easiest way that I can see to do this is to just add some text to this. So I'm going to use a function, so again, my equal sign called concatenate. And concatenate is going to let me take that value in that cell. Well, I'm going to say, again, in quotation marks, because of course this is value. I have to tell that it's a string, otherwise I won't understand. And I'm going to do that. So now I have val 84, and now I have something here that I can just paste down the way, and I'm going to take this, and now this is a formula, right? So this is that issue of is what you see what you get. So this is a formula. If I go to delete this, right, I start to end up with problems, right? Everything starts shifting around. So instead I'm going to copy, and then I'm going to use the paste function and choose paste special and use values. So this is a way to, within Excel, do that quote-unquote flattening that I mentioned that we get when we save an Excel down as a CSV as well. So it's a way to do it within the file, just sort of on our own. And now, if I select this data and I go up to my charts tab here, I can just say, look, I want a column chart. Never, ever, 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 ever use 3D charts, ever. And you see I get this chart that shows, wow, okay, there's, if we were to draw a line, right, we would kind of go, whoop. In a way, you could almost say, you might almost say that this is bimodal, right? Like I sort of noted, it's a little weird that everything that isn't a 99 is an 84. And, as we did analyses across the different supermarket chains, we would want to see if that pattern persists, right? Maybe it's impossible to get an 85, in which case that might change the way that we we treat kind of the separations between scores, right? It may not be very incremental, even though it sort of has this, it may be a sort of false sense of specificity, right? Having that numerical value, because maybe there's only like 5 values that ever really get assigned. So, again, this is the kind of stuff that can offer us insight and understanding, and that's the kind of thing we want to be able to share, with our readers and our audiences, and also to use on our own behalf when we're making judgments about data, making calls about interpreting it. So the last thing I'm going to point out with these things is that these are all checkable. So yes, you are being asked to do this by hand. However, in the long run, now that you know sort of how to do this, there are built-in functions in Excel that will execute all of these calculations for you. And there are some important distinctions. We will address in class what they are. And this is going to be another self-checking assignment. In other words, you will know whether you've gotten it right. And so we'll take a look at those in class and kind of discuss some of the nuances about those, because there are some subtle variations, particularly when we're doing things like standard deviation. And it's important to understand the difference between those. But in the meantime, hopefully this is sort of started to pique your interest a little bit. One last point I just want to make about the z-score, or the normal score, standard score, right? One of the things that's extremely valuable about the z-score, apart from this sort of clear translation to how many standard deviations am I from the mean, and how extreme is this value, is that because it becomes unit agnostic, right? It's only talking about it expresses the relationship between a value and its mean in a what's the word I'm looking for? In kind of an independent way. And what that means is that if we have multiple data sets, right? Last year we were talking about literally comparing apples to oranges. So, if I have one supermarket chain where the average, where the mean score is very different, it's a mean of 77 or something terrible like that. And a z-score, what I can do is, if I calculate the z-scores, I can see the relative goodness or badness of a particular rating within the scope of that with that chain's scores. Now, obviously that doesn't sound very interesting, but one of the things I would show, and we'll see, hopefully I can bring this up. This is a project I did while I was at the Journal, which was really, let's look at this guy. Okay, we're just going to hide my login here real quick. No, okay, hang on a second. Well, I may or may not be able to pull this up, but if I can't get this in a second, I will show you guys in class. That darn. All right, I'll try to get this another time. But basically, the best on the street is a series that the journal does that looks at how good analysts are at predicting making stock choices within their industry. And it's a challenging thing because the sort of highs and lows in individual scores are very different. But of course, across the board, you want to know, well, who's really the best, right? Who is the best out of every industry? Who's the best analyst? And that's something that being able to calculate a z-score lets us do. It lets us talk about percentiles, right? How good is somebody relative to everyone else, even if the scores that we have for them are not the same. So that ability to normalize is incredibly valuable when we need to compare different data sets. And again, really lets us actually do that apples to oranges comparison. So feel free to go ahead and give this a shot. I'll be posting your assignment data sets in the next day or two. I'll post the entire data set ahead of time so you guys can take a look at it. And I'll look forward to seeing you all next week.